Hello everyone, I'm going to introduce biochar production and its application. And I will start by what biochar means and how it's produced, and then give you some kind of introduction for such big applications of biochar, and then probabilities of biochar, and ending up with a simple method to produce biochar. Biochar is a stable carbon-rich product that is produced from thermochemical processes like torrefaction or pyrolysis or gasification. And in this schematic here, you would find something like feedstocks. This can be any material, basically biomass material like wood chips, corn stubble, rice straws, or peanut hulls, or animal manure, etc. And this basically, if we have this biomass and going to the pyrolysis, of course, during the pyrolysis or gasification, part of this is biochar as byproduct. So here is this, for example, in pyrolysis, you will find something like bio-oil and hydrogen. And this hydrogen and bio-oil can be recycled back as source for energy. And of course, there is some kind of heat produced also. And besides that, this bio-oil, and then we have also some kind of maybe this bio-oil can be upgraded for transportation and energy sources. And the byproduct again is the biochar. Biochar actually here can be used for soils. In reality, actually, biochar came from the application of the char that is produced from the thermochemical processes in the soil application. So basically, the biochar is just basically char. But if you use it as soil amendment, it can be called biochar. So I hope this is actually clear. So here, this basically the outlets here for this pyrolysis. For example, you produce biochar and syngas maybe, and also bio-oil. This again, this bio-oil and the syngas can be upgraded to other energy carriers, and it can be also used for industrial application. So this is actually what we mean by biochar. This is the topic of today. And there are actually some systems that can be complicated, maybe like these systems here, that's more controlled pyrolysis process, or just a very rudimentary or very simple system like kiln pyrolyzers, like this one here. This can be also just a very simple system that can be used for only biochar, because basically in this system you can't actually get the bio-oil or other product like hydrogen and syngas. It's actually mainly vented actually outside the system here. Okay, and this system I'm going actually to introduce a little bit later in details. What is the applications of biochar? Biochar has a lot of applications. Again, if we call it biochar, this is just used as soil amendment, and it's used actually for mainly for sandy soil to have potential to increase soil water holding capacity, and also it can improve soil quality, prevent nutrient leachate, and also as a sequester for atmospheric carbon dioxide. There are many applications for biochar. Again, it can reduce the methane from soils, of course, and it can also increase if we use it as soil amendment, of course, it can also reduce the emissions from of nitrous oxide from soils, increase nutrient holding capacity, decreasing the nutrient runoff, and of course reduce odors sometimes if you have some kind of odorous fertilizer. If you put biochar, it can also reduce this odor smells, and improve soil health. And of course, this can be reflected on higher product or higher crops yield. Of course, also the most important thing is that increase the carbon content of the soil. This is carbon sequestration as an application of biochar. Besides the soil application, it can also be used in the industry like filtration. and for wastewater and water purification, and it can also be used for as a filter for gas purification, and again for soil and groundwater remediation, and it can also be used as an element for solar or photovoltaic cells. Okay, biochar properties, there are several properties that can be assessed for biochar, and these properties depend on feedstock and pyrolysis or gasification temperature and residence time, and other process conditions. For example, if you have pressurized actually kind of system, it can also affect the properties of biochar. The biochar actually properties include the pH, chemical composition, nutrient retention, and CN ratio, surface area, and water holding capacity, particle size, density, and cation exchange capacity. If you look at here, again, this is just some kind of schematic here for the effect of temperature on some of the properties. For example, here, if you have temperature with the temperature increase, if you have this kind of 300 temperature to increase from 300 to 700, you will actually find the aromatic compound and the ash and pH, surface area, pore volume, this will be increasing. On the other hand, that the yield and volatile content of the biochar and conductivity and the cation exchange capacity will be decreasing with the increasing of temperature. So basically, this is positive correlation between these parameters, and this is negative correlation with this parameter with the increase of temperature of pyrolysis in this case. And here is I'm citing actually this references, so you can actually go back and do more research on that. So for example, here is the properties of biochar produced from almond shells. For example, here, if you increase the temperature from 350 to 550, you would find the organic carbon actually also increasing. And here, this is the surface area also increasing with the increase of the temperature, the surface area per gram of, or specific, actually, this I would say, this is specific surface area, this area, S should be A, so this surface area square meter per gram will be increasing with the increase of temperature. Again, here, this is also the pH increasing with the increase of temperature, and the cation exchange capacity would be decreased with the increase of temperature. How to produce this? Again, this is just a very simple system. This is basically biochar production using kiln, and this kiln is basically a barrel here. For example, if we have biomass material like shells, almond shells, it's actually filled with this shells, this barrel is filled with shells, and then put over some kind of bricks and start the reaction basically with some kind of starting point, like everything is open to the air. So basically you start the system for initiation, the reaction of pyrolysis. And then after initiation, you would actually have to wait maybe for 15 minutes to 30 minutes until actually the heat actually started to, or the temperature, or basically the content of the reactor, in this case this kiln, started to be heated up to a certain temperature. Of course, you can't control the temperature in this case, but you can wait for maybe 30 minutes until the top layer of biomass is still started to heat up. And with this kind of direct, actually, this kind of still, the system is still open. After ignition, of course, you will have to have, again, 30 minutes, and then you have to insulate it, because basically the pyrolysis is anaerobic. So basically, or there is no oxygen in this case. So basically what you do, you will get actually after the initiation of the reaction, you would take off this kind of bricks. So basically there is no oxygen anymore to go through the system. This actually, if you look at this kind of tubes here, this is just to distribute some air through the system so that this kind of dense biomass can be exposed to the heat from the initiation of the ignition process. After this kind of time, so you can actually take or put the barrel or put the kiln down on the ground, so there is no actually flow of air anymore through the system, and then seal the top with the lid for sometimes actually for 2 hours or for 3 hours, depending on the process that you would like to keep. Normally, maybe 2 hours is enough to produce this kind of biochar here. So again, this is just a very simple system for producing biochar in small kiln. And in this case, we get something like biochar yield is about 37% of the mass of the biochar of the shell of the almond shell that we used in this kind of barrels. Here, this is just some references for you, so you can actually go back and look at them. And with that, I would like to thank you. And if you have commented, leave them in the comment. Yeah, and see you next time. Bye-bye.